This is number 51 in chapter 10. It's looking at shape and polarity, and so we want to determine whether each of the following molecules is polar or nonpolar. And for that definition, remember, polar, you have a molecular dipole, while with nonpolar, you don't have a molecular dipole, right? No dipole. And so we have to draw these molecules in 3 dimensions and then ascertain whether there is a molecular dipole or whether there is no molecular dipole. And so part A is looking at ClO3 minus 1. If we put this structure together, we should end up with the chlorine in the middle expanding its octet, having then 2 double bonds with 2 oxygens and then a single bond to the oxygen anion. And so chlorine has 4 groups, and so we would write this structure in a tetrahedral electronic geometry. And what we find is that this gives rise to a structure that has a molecular dipole. In this case, that molecular dipole is pointing straight down. There's 3 bond dipoles between each one of the chlorine and oxygens and the bonding system that exists between them, but overall they are all pointing in that downward direction. So this would be an example of a polar molecule because of its geometry and molecular dipole. So that's part A. Part B looks at sulfur dichloride. And this is a really quick one that we should be able to put together. We would have 2 of the chlorines bound to the sulfur, which is also just going to want to have 2 bonds in order to have its octet. No expansion of octets in this example. And so this would be another example of an electronic tetrahedral geometry. So we end up with this type of structure. The molecular shape would be bent, and we have 2 bond dipoles going down the sulfur chlorine bonds, and so the net then is a molecular dipole pointing up and to the left, as I've shown with the arrow. And so since this has a molecular dipole, this is also an example of a polar molecule. Part C looks at now a further expansion of the sulfur example in part B. Instead of 2 chlorines, now we have 4 chlorines, and so that means our sulfur is going to have to expand its octet in order to have bonds to all 4 of the chlorine elements, and if it does that, then it still has a lone pair. So this would be an example of a trigonal bipyramidal electronic structure, and so we would end up with this 3-dimensional representation for the sulfur tetrachloride. This is a seesaw if we look at the molecular geometry, and so as far as whether it has a molecular dipole or not, we see that it has 4 bond dipoles, each along the sulfur-chlorine bond. The one that is pointing up cancels out the one pointing below, and the chlorine that's going back cancels to some degree the chlorine coming out, but there is an overall additive effect of now having a molecular dipole that's actually pointing from left to right. And so this molecule also has a molecular dipole, and so as a result it is also a polar molecule. And then the end, the last question, part D, looks at BrCl5. And so putting this structure together, we're going to need to make 5 bromine-chlorine bonds. And with bromine having 7 valence electrons, that means it still has 2 as a lone pair left over. That means bromine would be in a octahedral electronic geometry. And so here we have shown that electronic geometry for an octahedral molecule. However, since we have a lone pair, that's not the molecular geometry. The molecular geometry would be square pyramidal. And so what we notice is that all the bond dipoles between the bromine and the chlorine are about the equator of the bromine. Those are all going to cancel out, but we do have one that is pointing up that is not canceled, and that now is our molecular dipole. So again, since we have a molecular dipole, we also have a polar molecule. That is number 51.